for the battery mass. So we're going to look at circles. We've looked at this a little bit, and your understanding of circles has sort of been informed through your work on Desmos. Again, laptop down. For our circles, they take the general form of x minus h squared plus y minus k squared equals r squared. They often represent that as a and b. Why do you think I've kept it as h and k? What have we used for all the other functions when we've got a h and k? For a horizontal and a vertical shift. So remember there's a negative value attached with both of those. Cool? The r is our radius and it's squared. So it's very, very important that when we see a radius, we must square root it to actually determine what our radius is. So the first thing we need to do is sketch this function here. Where is it? Where's the center of our circle? 0, 0. What's the radius? 2. And we know with circles that they are. So if you've got something that looks like that, like a bullseye, and you've got 2, -2, -2, and 2, then you're in the right spot. Happy with that? Interval notation, that would be -2 to 2 for both range and domain. Cool. Happy with that? Everyone got that right? Sweet. So the second thing we need to do is, that's a pretty simple example. We haven't got any translations. Life is pretty good. I haven't really asked us to do too much that's funky there, but then the next part of the question I start firing things up. And I'm asking us to determine whether a point lies inside or outside or on the circle. So what's the first thing you think I should do here? Sketch the circle, okay? So where's the centre of my circle going to be?
2, -1.
Positive 2, -1. So that's the centre of my circle. What's the radius? 3. So I should have my circle going up to the point 2. I should have my circle going across to the point 5. -1, so I should have a point there and a point there, and then down to -4. Cool? Can't draw circles, you get the idea.
Which one was squares?
That is the world's worst circle. Cool. Okay, whatever, you get the idea. That's how it looks, something like that. We're all critics, aren't we? Now, to find out whether a point is greater than, inside or outside our circle or on our circle, we just need to shove our values in and see if it's greater than, less than, or equal to 9. If it's less than 9, it's going to be inside. If it's greater than 9, it's going to be. If it's equal to 9, it's going to be on the circle. Cool? So here, I'm just going to simply let 1 minus 2 squared plus -2 plus 1 squared. What's that? -1 squared is?
1.
-1 squared is?
1.
So that equals 2. So that point is inside. And we can check that. This is why drawing the diagram is helpful. If we go to the point 1, -2, we see that we are inside our circle. Happy with that? Now, it's important that I do this because some people might not be able to draw a very good circle. I'm not saying any of you guys, but some people in this room definitely can't draw a very good circle. So it's important that the diagram's there to help, but we're still going through and doing the calculations. Next point. -1 minus 2 squared plus -1 minus 1 squared is what? What's that? 9 plus 4? Huh? Is that plus, is it?
Yeah, because it's 1 plus 1.
It is 2. Yep. 9 plus 0 is? So what does that tell us? It's on the circle, that's that point there. How convenient. And the last point, -2 minus 2 squared plus 2, 2 minus 1 plus 1, squared equals -2 minus 2 is? -4, -4 squared is? 16. Either way, I know this is greater than 9. Or equals 16 plus 9, which is 25. 25 is greater than 9, therefore our point is outside the circle. I've got to now draw this point here, what was the other point? 2. That's my other point. Happy with that? Cool. Do we get circles? Pretty simple. Why don't I have a value in front of these? What do they say for? Ellipses. What's the difference between ellipse and a circle? It's an oval in shape. Cool. Happy with that? Exercise 4.3, question 4. We're not going to spend a lot of time on circles. Just a little bit.